Hyundai, the best car. All right. Well, welcome to the 6th week. Did you had a fun Monday? Yeah? No? Okay. Yeah, that's why I asked about yesterday. Right. Good. So any questions about matrices and rotation matrix and all that stuff? Because there will be a question in the exam quiz. Yes. Today we are going to quickly review what we did the other day, and I'm going to introduce you the matrices that we use for squashing and stretching very quickly. Make sense? Okay? And then you will work on your storyboard that some of you already working. Awesome. Okay? So we saw the Bezier stuff, and then we saw articulations. Yes? We saw DOF, types of hinges, and we saw this guy, yeah? Yes? The process of building a character. Yes? Yes? Okay, we didn't have time to view one important transformation, which is movement. We saw movement, shifting things, but we want to see stretching. So I'm gonna use my friend here, my favorite board. Let me see. Here. Very good. Cool, awesome. So we saw rotation matrix. For example, we could say this is rotation 45. Here you have your figure, and when you multiply this, you get this whatever. If this is a triangle, it rotates. Makes sense when you apply it, yeah? And you can apply another one later, and the effects compound, as we saw the other day. Question: what's the matrix if I want to do a squash? 50% squash. What is the matrix that accomplishes that? Any ideas? How would you do it? Yes? Nothing? No? Okay. Do you know this matrix? Do you know this matrix? Have you seen this matrix before? Never? Identity matrix, have you seen it? Yes? You've seen identity matrix? What happens when I have a point here, 3, 1, and I multiply it by the identity matrix? Are you sure? Let's multiply it. What do we get? 3 and 1. What happened? Nothing. That's why it's called the identity matrix, right? That's like multiplying by 1. So it's any matrix that has a diagonal of 1s and the rest is zeros. It's an identity matrix. Got it? Now, what happens with this matrix if instead of 1s here I have 0.5? What will happen? Yes, hold on a second. Yes? What will happen here? Divided by 2, right? So it's like, this is the same as saying divided by 2, identity, by my points. What happens is that the points get divided by 2, right? I can say identity 0.5, anything will be divided by 0.5. What does it mean, 0.5 in this case? Where do I draw this? Tell me hot or cold. It's here. It will be here, right? Yeah. And what happens with the point 1, 3? Where will it go? 0.5 and half. So it will go here, right? Yes. And what happens with the point 3, 3, 3? Right? Everything is rings. You get it? It's like zooming in, zooming out. So if I multiply by 2, what will happen? Expansion, right? Now, I want to do a squash of, imagine my object is a ball and it's falling, and I want to squash it like that. What's the matrix? But I only want to squash it like this. I don't want to make it small like this, just like this. What? Just the y-axis. Just the y-axis. What do you think? Just the
0,
0, 1, 0, 0, and 0.5. Very good, which is this, okay. And what will happen to this guy, for example? 3, 3? 3, 0.5. So meaning that the x, nothing changes, right? The any point in y, it gets squashed, yeah? But always reference point here, right? It doesn't, the point doesn't get squashed towards here, it gets squashed towards 0, 0, yeah? Okay? So maybe when you do this, you want to center the object in 0, 0. Sounds good? Because if the object is centered here, it will, in this case, it's okay. But if you want to do a zoom, if it's not centered, it will center not in the center of the object. Anyway, awesome. What about, I want to do a stretch because the ball is bouncing out to the space again. What's the matrix?
2, 0, 0.
Let's say I want to keep this distance the same as the original, but this is half.
So we will have the arrow and 0, 2.
You mean like this? Yeah? Yes? Yeah. Very good. Cool. Awesome. And let's say now that the ball is going to look like this, so I want to rotate it 30 degrees here at this point. What matrix can I use?
Cosine.
Rotation 30, yeah? So I would use rotation minus 30 degrees, and then the matrix called squash 50%, and then here I put my object. Does that make sense? You get it? Yes, no? So I have my object. In this case, it's the square, is the ball, right? So I want to end up with something like this, right? So first I will squash it. Yes? So this will make the ball like this, right? Let me draw upstairs. So we need to tell the computer to transform the original ball from here to something like this. How do we do it? So first I'm gonna squash the object, right, with a squash matrix. So I'm gonna call this matrix, which is 1/2 0, 0, 1, yeah? Remember? Yes. And then the object becomes like that, right? And then I want to rotate it like this. So the next step is to apply a rotation matrix minus 30 degrees. Because from here I want to rotate here, right? So from here I want to rotate here. That's minus 30 degrees.
Why not plus 30?
Because in mathematics, as you know, the angles start from here, right? So, right? Right. So, okay, cool. So what would you do? Would you imagine there's a million points here because this is not a ball, this is a very complex donuts from Toy Story 4. What would you do? Would you take these million points and then apply the matrix, squash, and then take the result and apply the matrix rotation? That's one option, right? So you can do the operations we need to do to arrive from here to here. Imagine this is the object is described by all these dots, which is a million dots, x, y, many, 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 yeah? So we can do this operation, the squash matrix, 50%, by this object, and then this gives the squash object, yeah, as a matrix of points. And then we take this and we apply the rotation and we get the final result we wanted, which is this one. Yes? How many operations do we do here? How many multiplications do we need to do? Let's look at this matrix. How many non-zeros we have? 2. So this means that at least we're going to have 2 multiplications. So a multiplication for each number here, right? So this number is going to be multiplied by every x, and this one by every y. So 1 million multiplications, another million multiplications, right? Yes? So 2 million multiplications. And the rotation matrix, how many non-zeros do we have? No, there's 0 zeros in this matrix, right? There's no zeros here. There's no zeros. In this matrix, there's no zeros. So it's going to be 4 million multiplications plus some additions, right? So this matrix, can anybody find me the rotation matrix minus 30? I think it's something like minus 30 half 0.867 minus 1 half 0.66. Anybody can find me the rotation matrix for minus 30? No? Yes. In 2D. So you can look it for 2D. Oh, yeah. So any cosine. So it's cosine theta. So it's cosine theta. What else?
0.
No. Yeah. Give me the square. Yeah. Minus sinus of theta. And then what do we have?
Sine theta.
Sine theta.
And then
Cosine theta. Theta is 30. How much is the cosine of 30? Anybody? Nobody? Bonus point. Who gave me the answer?
0.15.
0.15? Cosine of...
And radians.
Yeah. And I'm talking angles here, so no. How much?
No, just
Guess.
0.886.
Yeah, something like that. 0.86. So this is 0.86. This is what? Minus 0.5. 0.5. 0.86. Got it? So this is our matrix. Is there any 0? No. So this means we're going to do this for each point we have. We're going to do 4 multiplications and 2 additions. So at the end we will have 4 million multiplications and 2 million additions, right? So we're going to have, this is the cost, 2 million multiplications, 4 million multiplications plus 2 million additions. very expensive. Yes? But if you remember, I know that when you were studying algebra, you thought you would never use it in your life. But this is the time when you use it. But in algebra, there's this property where you can say, if I have two matrices together, multiply one and then your numbers or your other matrix, you don't need to do like this, first these two and then these two. You can do first these two and then the big matrix. You get it?
Yeah.
So you can do this first. What happens? Yeah, exactly. So what happens if I do this one first? So let's see, what's our A matrix here? It's the rotation matrix, right? And what is our squash matrix? So I can multiply these two. What's the cost? 4 elements by 4 elements. Less than 1 million for sure, right? It's like, what, 8 multiplications and 4 additions, right? Almost nothing. And then I do it, and then I only have to multiply the result matrix, which is also size 4 by 4, by my big number of points. Does that make sense? If I do it like this, the cost will be 4 million operations plus 2 million additions, right? So this is the first way to do it, and the second way, it's same as this. So I would save a lot of million of operations. Does that make sense? Yes? Algebra. You have Toy Story thanks to algebra, basically. That's what it means. Okay, so that's all for matrices, and we will not get more technical than this. That's it. That's it. I promise. I promise. I promise. Do you get it? Yes, no? Question for you. Last one, last question for matrices. Imagine I have an object, this house is my object, okay? Imagine I apply a rotation matrix minus 45. So first I apply minus 45, so the house ends like this. And then I apply so minus 45, and then I apply plus 45. Yeah? Yes, sure, right? Yes? Rotation matrix minus 45, multiply by the rotation matrix plus 45, and here I have my big object, which is the matrix representing a house. Yes? If I do these two first, as we said before, I should get the identity matrix, right? So you can check it at home that this is really true. Yes? Yeah, cool. Do you remember inverse matrix also in algebra? The inverse of a matrix and stuff like that. So this means that this matrix is the inverse of this one. It actually does the inverse. Do you get it? It has a physical interpretation. Yeah? Cool? All right, that's it. You can breathe now. All right, any questions about this?
How many questions would be on?
So you have quizzes from the previous year there, so you can see the midterm from the previous year and the quizzes, so you can practice. I will send it to you again. On Sunday, we will do the quiz for these last 2 chapters we saw. Questions? So I will send you sample quizzes. And we will do it online because Casiva is a fan of online testing. So. Right, okay. So what's important is that you practice that you can do these operations a bit quickly, not that it takes you 30 minutes. So do it 3 or 4 times at home to rotate points by hand, to do this and show me that that's it. We will not go more technical. Be careful with the order of things. In this case, it doesn't matter, but. All right, cool. Okay, and last thing. The last operation we see today, and that's it for operations. Imagine I have a ball. Imagine I have my ball here, and I want to move it to the right. What do I have to do? I want to move it by 3 units. What do I have to do? What matrix should I use? Anybody?
Just move.
You tell me what to.
The identity.
The identity?
Because we don't change anything, just we will change the place of it.
You don't change anything, just change the place. So what do I have to do?
I can change the x.
Change the x only. Can I do it with a matrix multiplication?
No. If we do the multiplication on the matrix, it will like squash all.
If you know how to do it, I'll give you the Nobel Prize.
No, we can
So
do
we
it
will add
like
it.
for using matrix, then redo it.
If you find it, I'll give you A+ and a Nobel Prize. Okay, so imagine this is the matrix, this is the x, and this is the y point, okay? So what we would do is to add
Another matrix.
what? Another matrix?
Or add number.
3.
Add the space.
3.
We change the x-axis.
I'm going to give you a clue. This is the vector that goes from here to here. I call it P delta. So what you do to your object, you just add P delta and that's it. Remember? Because it will add to every point. And halas. Okay? No matrix in this case. Got it? Yeah? That's it. Woohoo! Great, excellent. Wonderful. All right, cool. So now you have 30 minutes to start working on your storyboard. In the next sessions, we will have half class and you work half time here. Sounds good? And the idea is that you ask me questions. It's like I'm the producer of Pixar, and you must convince me that this is a good idea, the direction where we're going, right? Work without feedback from other people, the more risk that you are going in the wrong direction. That makes sense? So use me as a resource, not I'm your friend to help you get an A with the movie. Make sense? So storyboard, some people already start painting it. You can use post-its. You can do a small sketch animation, very crude animation, to see if it's really funny or not. You can do a small theater with your voices and stuff like that. All right, questions? Yeah, cool. Okay, let's go.